The reactions of esters are so easy. Let me just show you how easy they are. The second one which you're going to do is going to be ammonolysis, okay, which is similar to the one which you just did, okay. Ammonolysis, we know what happens. Let's kind of put an ester. I'm just going to put something here like this, okay. This is your ester, all right? Remember that it is a C, then it's like you can do it like this to say you have a, then here it's a double bond or, then here it's an or R prime. These are carbons, right? So what just happens in ammonolysis is, ammonolysis, just know that it doesn't touch the double bond. That's the only thing. It doesn't touch the double bond. It touches this other thing, which is not the double bond. So if I come and I add ammonia to an ester, it's the same as adding to a carboxylic acid. For carboxylic acid, OHO went, and we put NH2 here. And it's the same thing that happens here, okay? Because we can put it like this. We are going to have a C double bond O, but in here it's going to be an NH2. Okay, it's going to be an NH2 for this thing. It's going to go. Then plus one H is remaining, which is going to bond with this. And it's just going to be, or it's going to be your OH, okay, to an R prime. We can just put it as R prime OH. That's what happens, okay? The H will go. And you'll be having this. Now, this is ammonolysis, okay? It doesn't touch the double bond. It's the same for your carboxylic acid. Look, if I come back to carboxylic acid, it didn't touch the double bond. It removed this thing. That is what happened, and it put an NH2 there. Don't forget that, okay? I know you won't. Now, let's come back here, and let's go to number 3, which is going to be hydrolysis. Hydrolysis, hydro means water, and lysis is to break. So here we have acid hydrolysis is to use water to break, but in the presence of an acid. And this is how we like to put it. So it's like you're going to have your ester, okay, whatever way I can put it, the easier way, like we've been doing right now. Here is your ester, and then here's or R. So what I'm going to do, you're going to add water. We're using water to break, and in the presence of your acid, which is like H2SO4. And then what happens now? What then happens is in our hydrolysis is so simple because any hydrolysis for esters, any hydrolysis breaks it here. It leaves the O, it breaks here. So you're going to just have RC double bond O. Then here it's going to become an O, but here there is an H. This guy goes, okay? It goes like right here, okay, for your hydrolysis. It's not hard, is it? So it's going to go right there like that. And then you put an H here, then you're going to get this plus. This got the H. Remember that water has H plus and OH minus. So this OH will now come and join this R, because the R will being a little bit positive, and it will take the OH. Then this positive will come to this N, which will be negative. So that's what happens, and you end up having an R prime OH relationship. Okay, this is what happens, and that is the other product that comes. Then for base hydrolysis, it's similar. Okay, let's put base hydrolysis. What is the thing to remember on hydrolysis? We remember that on ammonolysis, we know what happens is you don't touch the double bond. On hydrolysis, you do on hydrolysis, you don't touch the double bond again. I'm sorry. You just touch here, just after the O. That is where you're going to put, and you put an H if it's acid. If it's base hydrolysis, this is how they like to write it. You see, for acid, they put the water, then they put the acid. Okay, they can just say H plus. It's still the acid. Tells you. For base hydrolysis, how they like to do it is they're going to give you the ester, okay, and double bond or, and it is or R prime. And what always surprises me is instead of plus your H2O and you then put the base on the arrow, they actually like to put the base here. This is base hydrolysis, okay? This is a base dissolved in water. What you must know is, how do I hydrolyze him? It's going to be the same. Where do you cut? Right here. Don't forget that. You cut right here. But here, what are the ions present? Here it's an Na plus and an OH minus. We know OH minus will come here, so Na plus has to come here. It's no longer an H plus, so it becomes RC double O. Then this is going to be O minus Na plus. So now what then happens is we then say plus, okay? What happens? OH takes this R prime, so it becomes plus R prime OH. Okay, and this is what you have in base hydrolysis. This is your base. Remember that we like to put it here, although for the acid we put it on top of the arrow, and here we put it as water. But anyway, that is going to be what happens in esters. Look at how simple it is. On hydrolysis, remember to break here, okay? And here, since you have Na, it's the one that comes in, OH minus is the one that is going to go to this R prime. Okay, and that's what you have. And this is all for it for esters. Goodbye for now. See you in the next one.